At this point, you've seen the basics of parametrics and how they work. We'll wrap it up by going through the process for the rest of the conic sections, so ellipses, circles, and hyperbolas, and also one other format that you'll see on the homework. So this one we should recognize as a circle from what we did on the other example on here. We've got cosine and sine, so it's going to be round, and it's going to be 5 in the x direction, 5 in the y direction, so that's going to be a circle, same radius both directions. An ellipse will just have different radii. And a hyperbola, there's a little bit of a twist to that one. I'm going to let you see how you handle it when you get to it on the homework. With all of these conics, though, if you see sine and cosine or any trig functions, generally you're looking to do a Pythagorean identity. So sine squared plus cosine squared equals 1. That was the Pythagorean identity that involves sine and cosine. So what you want to do with these is turn these into, or solve these for cosine and sine. If you solve this one for cosine, then you would divide by 5. And if you solve this one for sine, you would also divide by 5. So y over 5 equals sine of theta. And then you just go back to the Pythagorean identity. So sine squared, I left out theta, but same idea. If this is sine, then sine squared would be y squared over 5. And if cosine is x over 5, if you square it, you get x squared over 25. Oops, that should be a 25 as well. And it equals 1. Now that would look pretty good if that was an ellipse, being equal to 1, but since these are both the same, we want to go ahead and multiply everything by 25 on both sides. And that gets it in the standard form of a circle. And if you want to, you can put x first. It really doesn't matter with that part. 25s will cancel out, and this is now 25 on that side. So now it looks like the standard form of a function for a circle. Here's one where you're given a function and you're given a t value. And you're supposed to write the set of parametric equations that will go with this. So I would always begin with the t and just solve it for x. That's generally the way it's going to go. So I'm going to add x to both sides, so x plus t is 5, and finish up by solving for x. X is 5 minus t. And since I've already got one of those equations, I'm going to go ahead and kind of start it off this way. You can put an x with a little t there if you want, and y with a little t, or you can just say x equals y equals. It really doesn't matter. Technically, you usually see a x sub t right there. All right, now I'm going to put in what x equals in terms of t back over here. So y equals 5 minus 4 times, and again I'm plugging in 5 minus t for x, just substitution. So y would equal 5 minus 20 plus 4t. So y would equal negative 15 plus 4t. When I write this finalized, I'm just going to switch these so it's the minus in the middle. That really doesn't matter. It's pretty trivial. I just like the way it looks a little better. And that'll do it. There's your parametric equations. If you want to check these, you can always go to Desmos. Again, do a table where this is your x-coordinate, this is your y-coordinate. And then also do the function. And what you'll see is a dot. You also have to make a slider for t. But you'll see a dot that travels along the function. So this will create a dot, this will create an actual function. So one more time, you create a table, just go plus, do table, x equation, y equation, creates a dot. Make sure you introduce a slider for t, because t is not a variable, it's typically in Desmos. And then write your equation as another line, your function version. And the function will make a line, the table will make a dot. As you slide t, you'll see the dot travel along the line. That's how you can check to know you did it right.